All right, hello everyone. Let's get started with today's lesson 625. What do similar shapes tell us? Working with corresponding sides. Graphic artists often need to make a shape larger to use for a sign. Sometimes they need to make a shape smaller to use for a bumper sticker. They have to be sure that the shape looks the same no matter what size they are. How do artists know what the side length of a similar shape should be? That is, does it need to be larger or smaller than the original? Okay, so we're going to be working with these shapes and see how we go. So problem 686, and you should be writing this down. Please make sure you wrote down 625 on your paper. And problem 686. With your team, find the scale factor between each pair of similar shapes. That is, what are the sides of each original shape multiplied by to get the new shape? Okay, please be aware, like for this shape right here, this is the original. And then this down here is the new shape. So what am I doing to these sides to get the new shape, okay? So that's what I want you to do right now. I want you to tackle it. I want you to think about A first. So pause the video. Tell me what you think A is. What's the scale factor? What do I do to go from here to here, okay? When you're done, unpause it and we'll compare it. Okay, so hopefully you found this and you said, hey, what do I do with 6 to get 3? And again, the scale factor is something you multiply by. And what do I multiply 6 by to get 3? 1/2. Cool. So the scale factor is 1/2. And 12 times 1/2 gives you 6, doesn't it? So like 12 times 1/2, you multiply and put it over 1. 12 times 1 is 12. 1 times 2 is 2. And 12 divided by 2 is 6. So my scale factor here is 1/2. Cool. All right. Now, how about for B? This is the original. And this is a new. So please, once again, pause the video, find the scale factor, and when you got it, unpause the video. All right. This one was a little tougher, wasn't it? This was a little bit more of a pain, and you're like, whoa, wait a minute. 4 to get 5, you can't do that. Oh, yes, you can. Question is how? What do I do to 4 to get 5? Now, I do need to multiply, and like we talked about in class yesterday, if you multiply and you're getting bigger, 4 goes to 5, so it gets to get bigger. That means the scale factor has to be bigger than what? It has to be bigger than 1, doesn't it? Because multiplying by something bigger than 1 makes it bigger. So 4 times what gives me 5? It's kind of hard to tell. However, the scale factor that would make that work, 4 times 5/4 gives you 5. Like, how on earth is that? Well, let's see. If I put it over 1, multiply that. 4 times 5 is 20, and 4 times 1 is 4, and 20 divided by 4 is 5. So therefore, the scale factor here is 5/4. 5/4. Write it down, please. Okay? All right. Now, problem 687. It may have been easier to recognize the scale factor between the first two shapes, wasn't it, in part A of problem 86, than it was to determine the scale factor between the two shapes in part B, right? When sides are not even multiples of each other, like the sides 4 and 5 in part D or B, it is useful to have another strategy for finding the scale factor. So again, I wish you could work with your team, but I can't. But describe a strategy for finding the scale factor between any two shapes. And think about the questions below as you begin your discussion. So the first question, how can we use pairs of corresponding sides, and we'll talk about that in just a second, to write the scale factor? Will the scale factor between the shapes be more or less than 1? Okay, that's good to remember that number line we had and what numbers make something bigger or smaller, more or less than 1. And does it matter which pair of corresponding sides we use? Okay, now here's the thing we need to know. Here's the thing we need to address. What are corresponding sides? Shouldn't have gone that far. Okay, corresponding sides. If you draw a triangle, please draw me a right triangle like that. Okay, doesn't have to be perfect. That's fine. And let's draw another triangle that looks pretty much like it, and just like that. Okay. Now assume these. Okay, my pictures are not great here, but assume these are similar shapes, which means they're the same basic shape. All the angles are the same, just maybe bigger or smaller. And assume that we are saying, let's say this is let's say this is 5 meters. What side matches this side down here on this other triangle. Okay, well, the matching side is this. And so we call these, write this down, these are corresponding sides. Corresponding sides. And this one over here matches with what over here? It matches this one, right? Those are corresponding sides, meaning this over here and this over here are corresponding sides, okay? Now, this holds true. All of these corresponding sides hold true no matter how the shape looks. So in other words, if I go here and I take this triangle here, let me highlight it here. Come on, there we go. No, I don't want all of it. I just want this. And I take this shape and I group all these together. Check it out. This is what group. Oh, come on. Okay. If I take these though, and I take all of this shape, this whole thing, will it let me do it? Okay. All of this. And I'm going to group these together. Hang with me here, okay? I don't know if it's going to work, but I'm going to try. And I take all of the shape and I rotate it. Oh, it doesn't work for all of them. Oh, that's annoying. But no matter what, even if I put it like this green is always corresponding with this one. So no matter where I put my shape and how I put my shape, and if I go like this, and if I reflect it, or if I put it upside down, this side here is always corresponding to this one. Does that make sense? It is the matching sides of a shape. This side will always correspond with this one, and this one will always correspond with this one, no matter how you do the shape. Got it? So the corresponding sides are the ones that match up, and that's what we need to be aware of. So if I know that this here corresponds with this one, and this one's 15 meters, what is the scale factor? How do I find the scale factor? Okay, well, hopefully you see that and you're like, oh, well, that's easy. The scale factor is 3 because 5 times 3 is 15, right? 5 times 3 equals 15, so this is my scale factor. However, what if this was 12? 5 times what gives me 12? Ah, that one's a little tougher, isn't it? 5 times what gives me 12? How can I find this number? Always. Now look at the hint it gave you. Can we use pairs of corresponding sides to write the scale factor? And you're like, what on earth? Corresponding sides to find the scale factor. Well, let's backtrack here. Let's go back to when this was 15. Now we know the scale factor is 3. How can I write 15 and 5 in a way that gives me 3? How could I write that? 15 and 5 to get 3? Well, hopefully, what do you think I could do? 15 over 5 is 3, isn't it? 15 over 5 is 3. So now, if I take this shape and I say, oh, this scale factor is 12 meters, how do you think I could write that in order to get that scale factor? Well, 12 over 5. And guess what? 12 over 5 is my scale factor. You're like, what, really? Well, let's try it out. I know this 5 times this should give me 12, right? So if I do 5 times 12 over 5, and let's try it out. I'm multiplying fractions, so I put it over 1. 5 times 12 is 60, and 1 times 5 is 5, and 60 divided by 5, guess what? It's 12. So my scale factor is going to be 12 over 5. Now, here's the tricky part. If I was going here and saying that now, well, let's go with the 12. This was my original, and this is my new shape. Now I'm going from 12 to 5. So 12 times my scale factor gives me 5. Well, the strategy we just found out is we can take these corresponding sides and write them as a fraction, right? So what I write, 12 over 5 or 5 over 12. One of those scale factors is correct. Question is which one? Well, let's address this. If I'm taking 12 and I'm multiplying it and getting 5, this number here, does it have to be bigger than 1 or less than 1? Greater than 1 or less than 1? Well, the value got smaller, which means 12 times something less than 1 would make it smaller, right? That's what we said. Multiplying by something less than 1 makes it smaller. Which one of these is less than 1? 5/12. So my answer here should be 5/12. 12 times 5/12 equals 5. Does that make sense? So the cool thing is, here it is. Write this down. To find the scale factor of any two shapes. Number 1, find corresponding sides. Let's find a pair of corresponding sides. Step number 2, write as fraction. Now, not just any fraction, right? As a fraction, what over what? Okay, what should it be? Right, as a fraction, what over what? Is it the new over the original or the original over the new? Okay, again, look at this. If I'm going from, if this is the original and I'm going here, what did I write? I wrote 5/12. So new over original. And that is your scale factor. Cool? That would be your scale factor. And then so step number 3, if possible, simplify. Because I mean, if you get 10/2, don't write 10/2, write 5. So do simplify at the end. But that is how you find your scale factor, okay? Tomorrow when you come to class, we're going to use this skill and we're going to apply it to some new scenarios and some different situations. So hopefully this makes sense. And I'm really hoping you watch this video, because if you didn't, can you imagine trying to catch up in class without having watched this video? So hopefully it makes sense. Cool. All right. Thank you very much. And I will see you tomorrow. Have a great evening.